Welcome to the Bytecode, where we look at smart contracts with the people who wrote them. I'm your host, Shafu, and today's episode is with Philip, who is going to walk us through the circuit breakers. Philip, thanks for taking the time, dude.
Hey everyone, I'm Philip. I'm a smart contract developer. I have been into crypto since 2016. I've actually jumped into coding when I was still 11. So I've had, in terms of years, a large coding journey already. In terms of smart contract development, I've been doing that for 3 years. Uh, Mostly been focusing on DeFi, but since roughly 1 year, I jumped more or less into the security ecosystem, but not as an auditor, but as someone who's driving to find a solution to hacks in DeFi using code. That might sound very much like a paradox, but what this means is basically proactive security tooling for smart contracts. And that's what circuit breakers are. And I'm basically also working on this EIP called EIP 7265, which is the circuit breaker EIP. And what we're trying to do there is crafting a standardized implementation for all circuit breakers across DeFi. So you might wonder, what is a circuit breaker? Well, a circuit breaker itself is a set of smart contracts which allow you to track critical protocol metrics on chain. And it basically allows you to define certain thresholds for these metrics, and basically define certain conditions that these metrics should never reach. And basically, you can use them as invariants in your smart contract code to assert that something should never go out of bounds. And what this allows you to do is you can track critical metrics, for example, TVL directly on chain, and define thresholds for example, for TVL withdrawals. So you could say, hey, if my protocol is getting drained of, let's say, 30% TVL within a very short time frame, that's probably weird. And that's where I might want to step in and have a look again what's happening before the code is getting executed. Maybe let's jump right into the code base. By the way, you can find this code base in this repository. I think it's going to be in the video description somewhere.
Yes, for sure.
And what this repository is it's a fork of the original EIP's repository, because that's how you submit EIPs. And when you are in this repository, what you have to do is you have to go into the assets folder and then write down to EIP 7265. And this is where the code base lies for the circuit breaker. Because there are also code bases for every single other EIP inside of here.
That's actually really interesting, Philip. Maybe
Right.
if you can talk a bit more about the EIP process. That's really weird that you have one code base with
Yeah.
all EIPs in it.
Yeah. Basically, so basically how it works is you fork the EIP repository, you add your code. The assets folder is actually not mandatory. It's only if you have code that you want to submit. An EIP does not necessarily have to contain code. And what you do here, you add any stuff that you want to have, and then I think you create a PR on the repository, and that's how you submit your EIP, and that's when the discussion starts. Yeah, but actually, interesting enough, the EIP 7265, currently it's an EIP, but we're gonna restructure it to be an ERC, because there's actually one more interesting thing regarding EIPs. So there is an EIP called EIP1, which was the first EIP ever. What it is for is it's basically just to define what an EIP is, what an ERC is, what should be submitted as an EIP, what should be submitted as an ERC, and what the different basically clarification for the two. And what we're trying to do is standardize code, and that's not something that is going to change the core implementation of Ethereum or the Ethereum nodes. It's more like an ERC, an Ethereum request for comment, basically a community request for comment to discuss something in the community. So
Mm.
we're going to submit it as an ERC at the end.
Okay.
But yeah, EIP process is actually very interesting. And also drafting an EIP or an ERC, at least the writing has to be, for example, very, let's say, academic in a way. It has to be very,
Mm.
very formal, the whole thing. Very thought out. You shouldn't really, I mean, you can submit something that is not, let's say, perfected till the end. But from what I've been seeing is that you should rather do something or submit something that is really thought out. That's actually why our proposal is not yet submitted on the main repo. Right now, it's a draft because we want
Mm.
to really perfect everything before we start a huge public discussion. So yeah, it's very much in its development yet, and there's a lot of iteration going on the EIP ERC. Sorry. Um, so yeah, um, that about EIP and ERC. So maybe let's jump into the code base. Um, so we got source, right? So the code base is actually, there are a couple of different things. So we have our interfaces. We have three core contracts. We have a settlement folder, a static folder, and a util folder. Maybe let's talk about the interfaces first. So this is the IERC 7265 interface. And what this interface basically specifies is how a base circuit breaker contract should look like, what events it should entail, when they should be emitted, what functions should be there, what purpose of the function, or what purpose the functions have, and also what logic. So maybe we can go over the most important, the more important stuff. So here we have a couple of events, but maybe actually let's talk about the functions first. So this is actually one of the most important functions here, which is called increase parameter. And before we talk about this function, actually we have to clarify one thing. So in the beginning, I talked about the circuit breaker being a tool where you can track protocol metrics. And these protocol metrics internally are called security parameters. And at the base, they're really just numbers. And you can increase and decrease these numbers. And each number, each security parameter has an identifier because you can define multiple ones. Then obviously, if you want to increase the value, you also have to specify an amount. And then there are these three weird values: settlement, target, value, and payload. And what these are actually used for is, actually, this is a more advanced feature of the circuit breaker. So I talked about the circuit breaker being able to identify if a certain metric has reached a threshold. But what actually happens if that metric has reached that threshold? What happens then? And this is what the settlement stuff is for. So the circuit breaker allows you for every single security parameter to define a so-called settlement module. And this is a separate contract that gets called whenever that happens. And for this, you can basically specify three things: a target value and a payload that might be used inside of that settlement module for some kind of function call. So yeah, the settlement module is a separate contract. Actually, we have two standardized contracts here, and this is its interface. It's very, very simple. But in essence, the prevent function of that contract gets called. And what you can do there is you could, for example, if you're handling funds and maybe you're tracking TVL on chain, which is probably one of the most prominent use cases for circuit breakers, you could, using the settlement module, freeze these funds and then use the settlement module as a time lock contract. Basically delaying the transfer, locking the funds, and then allowing governance to come in and unlock the funds on the settlement module on the time lock. And that's actually what our delayed settlement module is doing. This is an Open Zeppelin time lock controller contract. And within the prevent function, it schedules a payout. So it basically receives funds and it schedules an action, and using governance that could be executed later on. So that's a more advanced side stuff. But again, this is an optional feature that does not necessarily have to be used. So in these functions, increase parameter or decrease parameter, these could be default values as well. The settlement target, value, and payload. So in a more basic implementation, you just need the identifier for the security parameter, which is a metric that you track on chain, and an amount. Right. So what else do we have here? Well, obviously, add security parameter. You have to initialize a circuit breaker with different metrics that you want to track. Update a security parameter that is basically updating the configuration for an existing security parameter. And actually, let's talk about the configuration. So when you add a security parameter, there are 4 values. The first one is the identifier, which obviously is the identifier. And then the second one is min val base points. What this means is this is a value in percent that the metric should always retain. So let's say you choose 80%, and that means that the value of the security parameter cannot decrease by more than 20%. It always has to have 80% of its value within a given time window. So if you use TVL, for example, and you track TVL or token balances, this basically specifies the minimum value that you should retain in the protocol for the token balance or the entire TVL. Then there is also a limit begin threshold, and this is an absolute value that might be used. Again, this one is optional, but it might be used. For example, imagine you're deploying a new protocol, and in the first few weeks, you probably have a lot of fluctuation in your TVL, and as liquidity comes in, you have a lot of inflow, right? And to prevent, and also if somebody withdraws a normal amount, that might account for a huge amount of the TVL because the TVL is still so low. What this value allows for is to set an absolute value that the parameter has to have reached before it becomes active and the circuit breaker tracks if it retains the minimum value. So this basically prevents new protocols from getting the circuit breaker triggering right at the beginning when the protocol is only starting.
Yeah, Philip, I have a question here. So I get the min value BPS, but where do I define the time window?
Right, that's actually on a circuit breaker wide configuration as of right now. We're working on changing that because it would make, well, you might want to have different time windows and entirely different configurations for different metrics. But right now, that's a global value within the circuit breaker contract, which you define in the constructor.
Okay, right now, one global time window for our security parameters, basically.
Yeah, right.
Okay.
This basically, the reason why it is that way is because at the beginning, we only thought of the circuit breaker being only serving one purpose, which would be TVL tracking. And we had actually the concept of security parameters didn't exist back then. We were only tracking tokens and token balances. So and that's how we were tracking TVL, and that's where that comes from. Then we changed the concept to a more broad terminology and more general use case of security parameters, and it's still in the development. So it's the security parameters already exist, but the configuration, some of the configuration values are still global. But this is something that will change. We want to have, obviously, you should be able to define custom time windows for different metrics, because you could track entirely different metrics which are vastly different from another that require different time windows. So yeah. And the last parameter of the security parameter configuration would be the settlement module. as I explained earlier, that's a separate contract that gets called if the security parameter has been has reached its threshold. If you do not want to make use of the settlement module feature, you still have to deploy one empty settlement module, which you use for all of these, because the circuit breaker just calls a prevent function on it. It does it every single time, and if you want to opt out from using that, you just have to have an empty implementation in the prevent function.
Okay, interesting. Why not just check if the settlement module is empty or something? Like the zero address.
Yeah, we could also do that.
Okay.
That's perfectly valid. But right now, how it is implemented in the circuit breaker is that with every single, if it triggers, it just calls the settlement module, and it also sends the value, the settlement value, and the values that are defined here to that contract. But yeah, this is something that could very well change. We could change it to maybe checking for a default value and then not doing that would also probably be more gas efficient. It's totally valid, yeah. Okay, so jumping back, well, the update security parameter, it updates the configuration. Then we have a couple more functions. Is parameter rate limited? That's basically just another phrase for is the parameter triggered right now, where you pass the identifier and it returns a Boolean. Then we have a function called add protected contracts, which adds. So every single security parameter, every single circuit breaker has a set of smart contracts that are allowed to modify the security parameter values. And this is what the protected contracts are for. And basically, they have special permission to either increase or decrease a security parameter. Then there's also the operational status. So you can turn on and off the circuit breaker. You can also, through governance, override a security parameter trigger event. So you can untrigger it. And then there's a grace period and a function to check if it's if it's currently in the grace period. So grace period is a special period that you might want to set to deactivate the circuit breaker for a specific amount of time. Why is that? Well, for example, if there are very, very abnormal activities going on chain, then you can, for example, imagine wrapped Bitcoin depegs or something like a black swan event. Then you can basically specify grace period, and in that amount of time, the circuit breaker does not trigger. So it allows for everyone to withdraw their funds without the circuit breaker preventing them to do so. Okay. So yeah, and then we also have an interface, obviously, for the settlement module contract. We have an interface and also an interface for the second circuit breaker, which is in the core folder, which is the asset circuit breaker. And this circuit breaker is actually what the original circuit breaker used to be. So this is a pre-built circuit breaker if you're intending to only track token balances. So this circuit breaker has, you can see the event naming. It's specific to asset, so basically token and native tokens, and it has pre-built methods to allow you to automatically track token balances, adjust them, register a token, and so on. But under the hood, what it does is it uses the circuit breaker. By itself, this contract is a circuit breaker. It inherits all the functionality, but it just has wrappers around every single operation and some special operations as well to make it easier for you to do that out of the box. Because, as I said, this was the default implementation at first, actually, on the EIP. And this is due to probably the most likely use case of the whole circuit breaker is probably going to be to track TVL, because this is one of the most critical values uh, that you have on chain, and also one that is one of the most indicative values if something is going wrong. Because at the end of the day, with every single hack, what happens is that a lot of liquidity is getting stolen. So TVL is always a metric that gets some kind of bump or a deviation with every single hack. So it's also an easy value to identify if something weird is going on.
Yep.
And also another contract in the core folder is the protected contract. And what this contract is it's basically a pre-built contract that protocols could inherit to automatically have tooling for using the circuit breaker, using the ACID circuit breaker, and recording token inflows and outflows. So this is also a standardized contract for that. And it contains methods for if a transfer happens, an inflow and outflow, and also for native assets.
Interesting semantics that you always notate the function with CB.
Yes, it means circuit breaker.
Yeah, it's like
In
a
this,
C thing. I've never seen this in Solidity before.
yeah, true. Yeah,
Okay.
it just means a circuit breaker. Circuit breaker
Yeah.
inflow. Yeah. Okay, so maybe let's jump into the more interesting stuff, which would be the implementation of the core-based circuit breaker. This is basically the core component of everything. And what you as a protocol, in order to integrate a circuit breaker, would have to do is to actually deploy this contract, a new one for your protocol, and then you can use it. You would have to configure it with protected contracts and also your security metrics, and then you can integrate it into your protocol to track metrics. So yeah, and here is actually what you asked about earlier. So this withdrawal period variable is actually the time window that is being used in blocks to reference, basically to reference if something weird happens, or to reference the deviations within the time window. This is the amount of blocks for that time window which is being used to reference that. There's also one more interesting thing about this, which is the tick length. So under the hood, what we actually do is we don't record every single. We do record every single parameter deviation, but to make it more gas efficient, we store it in ticks. And this tick length is also a number of blocks. And basically, you could specify it to have 1, 2, 3 blocks put together into one entry into the list of values for the security parameter. And as the bigger this is, the more efficient it is. Basically, the recording of the security parameter values, but you lose in detail. So you lose. It's less detailed basically. If you chunk the changes of 2 blocks, 3 blocks, 4 blocks together into one entry, it gets less and less accurate. So this is the downside of that. Then operational, we talked about that earlier, just if the circuit breaker is operational or not. Rate limit and timestamp. Rate limit, again, is just another word within the circuit breaker code for if it's currently triggered. And we basically record the timestamp. This is basically the timestamp that. Oh, I think I forgot to explain something. So actually, let's explain the cooldown period first. So the circuit breaker has a cooldown period, and this is a period of time that after which the circuit breaker automatically untriggers again. And the current time and the rate limit and timestamp is just the timestamp that the circuit breaker will be able to be deactivated again. And this is stored for the function. We're going to look at it later, but there's a function to check if the circuit breaker is currently triggered. Circuit breaker triggered meaning that one or more security parameters have been breached, and this variable is basically there for checking if the timestamp for that has passed or not. Hence, if the circuit breaker is triggered or not. And there's also this grace period, which I explained earlier, is the period that which is optional, but you can deactivate the circuit breaker for a specific amount of time if something weird is going on the blockchain, and you know that it might cause the circuit breaker to trigger, even though there's nothing malicious going on. So yeah. Then we have some modifiers to check if the caller is one of the protected contracts, if the circuit breaker is operational. Then here is the constructor, where you basically set, right now globally, the time window for which is being used for all the security parameters. Then there are the functions for adding protected contracts and removing protected contracts. Then functions for adding and updating a security parameter. Let's have a look at that. So this is also where something interesting comes in. So the circuit breaker makes use of a library. This is the limiter library. And basically each security parameter has a limiter struct, which contains all the configuration for the security parameter, and also stores all values of the security parameter over time. And what this limiter library is for is it's basically there to facilitate checking if a certain security parameter is breached. It's there to record any change in value for a security parameter. It's basically a library which has the logic for doing that, for recording a change and then for recording a value change and then checking if the security parameter has been breached or not, and also keeps track of all the values over time within the time window. And right now the limiter library is very, very gas inefficient. I have to say that we use storage a lot. There's even the struct itself. We have nested mappings. We have a lot of things which make this very inefficient. For L2s, it's probably not really a problem, but for mainnet DeFi protocols, using the circuit breaker with this limiter library is probably would increase gas by a noticeable amount. And what we're also currently doing is actually coding a complete revamp of this limiter library to really only have the bare bones functionality, which should be recording a change in the value and identifying if within the current time window the changes have surpassed the threshold of a given security parameter. So we're right now really revamping this whole thing to make it way more easier and also more understandable to read. Because if you go through this limiter library, actually a funny story. So when I joined the EIP effort, the limiter library was more or less the same as it is right now, and I actually had to spend considerable time to get used to the limiter library and what it's doing, and really understand it thoroughly, because it's a little bit complicated to read in terms of the code. But yeah, this is basically just there to record changes, record value changes, identify if the circuit breaker has been, if the security parameter has been breached. This is more or less what it does. Its functionality, or the idea behind it, is rather simple, actually. So let's maybe go back to the circuit breaker. So yeah, when a security parameter gets added, the limiter, a new limiter is being initialized using the limiter library, and also stored in the circuit breaker. The circuit breaker keeps track of all limiters, which is basically a list of or a record of all the security parameters and its configurations and the current values. Update security parameter, it updates the parameters on the limiter itself. Increase parameter, this is something that is more interesting. So increase parameter calls the limiter, which is the struct that we have talked about right now, and uses the record change function to to basically record that value change. And then it calls the status of the limiter, checks if it's triggered, and if the circuit breaker is not in a grace period, because remember earlier, if the circuit breaker is in the grace period, actually the security parameters are allowed to trigger. And what happens here is that if the circuit breaker triggers, an internal handler is being called, and what this internal handler does again is it just calls the settlement module prevent function, and it also sets the security parameter to being triggered, and also the global value of the circuit breaker to indicate that one or more security parameters are currently triggered. And what's actually, yeah.
Yeah, I have a question, software organization wise. You have a lot of functions that call exactly one internal function.
What's the
Why?
reason for that, right?
Yeah.
So this is because the asset circuit breaker also basically just a code organization, because the asset circuit breaker does not want to have, it doesn't need to have these public decrease and increase parameter functions. It has other functions. Basically just a function that is named differently, does the same thing, and then calls this same internal handler. So it's just a design choice to basically not have the asset circuit breaker also have redundant functions like the public decrease parameter function, but instead just have a different name for it. So that's the idea behind it. Basically allows the circuit breaker to the base circuit breaker to have functions called increase parameter, which is public and can be called from the outside, and inside of the asset circuit breaker, let's see, yeah, right. So increase or decrease parameter. This is just called on token outflow here. It also handles the data creation for the settlement data. But what it does under the hood is it also calls this handler, this internal decrease parameter handler. So it's just there to make sure that the asset circuit breaker does not have these bare bones decrease parameter functions, because it inherits from the contract.
Okay.
Yeah, that's basically the idea behind that. But again, this might be subject to change. But that's basically why the design is the current way, that we have these internal handlers, which these are actually the ones implementing the logic. And then we have these external functions, which are there to then indicate if it's, or basically leave it up to the outer layer contract to how the function is called that will initiate these underlying internal handlers. Yeah, hope that makes sense.
Okay. Yeah.
Actually, at the beginning we didn't have that, because we only had one circuit breaker, which was more or less the asset circuit breaker, and then this logic for example the increase parameter was just baked into the on token outflow function. Oh, sorry, decrease parameter in this case. Yeah. So yeah, that's the reason there. Okay, so right, so we also have, of course, an internal handler for decreasing a security parameter. Actually, what I forgot to say about this is that it uses two modifiers here to check first if it's first to check if the caller is only is verified, basically one of the protected contracts, which should be contracts of the DeFi protocol. And if the circuit breaker is operational, because if it's not operational, if it's turned off, then it doesn't accept any changes to its state. And yeah. And here, more or less the same thing happens. So it records that change using the limiter, and then it checks the status, it checks if it's triggered, and if it is, it again calls the internal handler for if the circuit breaker is triggered.
Yeah,
And
maybe
actually,
one really small detail,
yeah,
gas-wise. I think it would probably
yeah,
make
gas.
sense to do only operational before only protected, right?
Yes,
Because,
that's
yeah,
absolutely valid. Yeah,
mm,
because operational it just checks a boolean, and then only
yeah,
protected is looping through a couple contracts. Yeah, that's true. Yeah. Um, okay, and also what's also important here is all these decrease and increase handlers return a boolean to indicate if the circuit breaker is triggered or not. What this is really useful for is for users of the circuit breaker, for example, protocols that do not want to necessarily make use of the settlement module functionality, but still want to know on the protocol side if the operation has triggered the circuit breaker, or the circuit breaker is currently triggered during an operation that modifies the value of a critical protocol metric. Because then if the circuit breaker is triggered or the security parameter threshold has been breached for that value, you will probably want to have certain logic on the protocol side as well to account for that. For example, to stop further execution. For example, if you want to take a very conservative measure and it's a very highly critical value, such as the TVL, you might want to check the Boolean and maybe even just return at that point if it really goes out of bounds. So that's what these Booleans are for. And then, as I explained earlier, this is the handler for calling the settlement module, specifically the prevent function of it. And actually, what I forgot to mention earlier is that the asset circuit breaker, which is for automatically tracking token inflows and outflows, it also automatically makes use of the delayed settlement module. And I think I showed this before already, but what this does in combination with the asset circuit breaker is that if there is a token outflow that reaches the threshold, or within the time window at least, the token outflows for a given asset have breached the critical values, then the funds from these transfers will get transferred to the delayed settlement module, and the asset circuit breaker automatically accounts for that and computes the data which is being used for the delayed settlement module. And this delayed settlement module will then handle the incoming transfer and also automatically schedule a future transfer for releasing the funds again, which is super cool because that way you can have a more decentralized way of handling a circuit breaker event, because a circuit breaker itself can be, well, it depends, but the circuit breaker itself can allow for very, very centralized solutions to mitigating protocol risk, which is not necessarily what we're thriving for. We're obviously want to keep the Web3 ethos and have decentralization reign over centralization. And using something like time lock for freezing the funds is, at least if you're using it in combination with governance, a more decentralized way of managing a circuit breaker event. So you can have very complex logic or handling uh, of when your circuit breaker triggers. But on the other hand, you can also have very simple implementations and just check the Boolean that gets returned from the circuit breaker and then do something very simple, like just even like reverting the function, returning the function. Yeah, you can also have very simple implementations there. Yeah, so that's one broad overview of the whole thing. Um, Actually, we have one more interesting thing here. So we have actually done some quite intensive testing of the circuit breaker contracts as they are right now, and so we have basically tests for the core contracts, also for the settlement module integration. And what we have also very recently added is a proof of concept. Well, proof of concept, a more sophisticated proof of concept, I'd say, that actually encapsulates a hack that really happened, and then prevents the hack using the circuit breaker code. And it uses a bridge that got hacked, I think 1.5 years ago. The Nomad bridge, and the Nomad bridge was hacked of, I think it was $150 million. Actually, bridge hacks are are actually the most lucrative hack scenarios, because they just hold a huge amount of funds that can get exploited. And bridge hacks is actually something that we never thought circuit breakers might be really useful for, because of the complexity of having uh, cross cross train communication. But we tried to integrate it into the Nomad bridge, and it worked. And we're really proud of that. And it's also part of the EIP or ERC repo right now. And we basically integrated the circuit breaker into the core contracts of the Nomad bridge, which I think can be seen here. So we did something very simple, just for a proof of concept. Basically, we recorded every single outflow of the contract that is responsible for giving out tokens on the destination chain, and we just checked if the amount of tokens flowing out of the bridge reaches unrealistic amounts. And this was basically able to prevent the hack from going through again when being simulated locally, because the hack actually drained all the funds one by one, because the security vulnerability within the Nomad bridge was very great. It basically allowed for draining the entire token balances of tokens just one by one. Was very grave security implication. But yeah, we basically, so we did some research there as well, and it's now part of the core EIP repo, where we showcase that actually hacks that have happened could have been prevented with the circuit breaker integration. But yeah, this is more or less that.
Nice. Maybe if you can talk about timeline-wise. I know the
Mhm.
EIP or ERC process is basically unpredictable.
Oh yeah.
Uh, so how is that going? How are you planning any audits or stuff like that?
Yeah. So right now we're still in development phase. We have thought about audits, but we really want to polish the contracts. As you've seen, there are some things that might want to see some improvement in the code base, especially in regards to the limiter library, because it's highly gas intensive. So right now, what we're focusing on is developing further, um, and then probably doing an audit, and then formally submitting the ERC to the Ethereum community. That's kind of the
Mm.
timeline. But unfortunately, EIPs and ERCs have a track record of taking a huge amount of time for adoption.
Mm.
Um, so yeah, my estimate is that probably early next year we're probably going to do like at the end of Q1, Q2, we're probably be finishing with the development process, at least the first version of it. Then we're going to do audits, which uh, could also require us to do some more rework. So Q2, Q3, we will be probably submitting the formal ERC to the community, and then it can take years, to be honest, or it will most likely take years to
Mm.
get formal adoption and also to get the conversation going around this.
Okay.
Yeah, it's unfortunate, but it's how it is. But on the other side, once the conversation is going, this is actually one of the main objectives we have with the circuit breaker is to raise awareness about on-chain protocol security and on-chain hack prevention. And this is actually one of the core or the main focuses we have right now to raise awareness about this, because we know that this is actually there have been some people already working on circuit breakers for quite some time. Even Gauntlet, which is a huge or a highly respected research collective doing work for Aave. They have and are experimenting with circuit breakers. Actually, especially for Aave, they call it kill switchers. So very highly respected security researchers in the space are already thinking about something like this, and we really want to take it further. And we really think that this is something that could potentially solve the problem of uh, the vast amount of exploits that are happening in DeFi as of right now. And it could be a go-to hack mitigation tool that people could easily integrate with and have as a second line of defense apart from their code base against getting hacked. Um, we don't know necessarily if this is the ultimate solution to everything, but
Mm.
we are there to explore ways of how we can solve the current problem of hacks, because it is a big problem.
Yeah.
Audits alone are unfortunately not enough. Like, actually, my opinion is actually, or I would love to strive for good code before having to write code specifically to counter any bugs in my code. Like in I would prefer a world where we would not have to write code like circuit breakers and write these tools to account for bad code. I would love to have just good code and strive for the best code we can produce for our production contracts. But it really is not enough as the current track record goes, and there needs to be some kind of solution to that problem. And yeah, circuit breakers could very much be the solution to that. Maybe they're not. We don't know, but something aside from audits has to has to gain the mainstream to account for the current security implications.
Mm.
That's just how it is.
Yeah, it's basically another line of defense, and I think maybe as well like training wheels. Like you deploy something, and after 4 or 5 years, you have like billions in TVL, and everything is all right, and then you can think about maybe I don't need that stuff anymore. But
Right,
especially
right,
in the beginning, yeah, makes sense.
exactly. And also, um, this is also, I think, something useful for maybe teams that do not have a huge amount of budget, which
Mm.
maybe uh, can do 1 to 2 audits before they deploy, but then have a very scarce security budget. So maybe this is also something that teams with low budget can use to, aside from audits, um, from a low number of audits, maybe to counter that a little bit. with a lower budget, because this is publicly available. Anyone can use it, and it's really just it's a public good in a way. The circuit breaker stuff, and especially for these teams which do not have infinite amount of resources they can spend on security, I think it makes sense to have something like that.
Definitely.
And then also use it as a training wheel for the production code.
Yeah, for sure.
But yeah, it happens everywhere, right? Aave had to shut down. The curve hack happened in July, I think, right? So even big players are affected by that, and yeah, there just needs to be some kind of solution. I don't necessarily know if circuit breakers are the thing to solve that, but I think it's worthwhile pursuing that and testing it out.
Yeah, for sure. Philip, awesome, man. This was a really great presentation, dude. So thank you
Thanks
for
very much.
that. If people want to reach out to you, what's the best place?
Probably Twitter. Maybe we can put my Twitter in the description or something.
For
Would be very
sure,
cool.
for sure.
Also, there's a Telegram group for the circuit breaker, for the EIP. You're free to join there if you want to contribute. We're always looking for people who are passionate about security and want to do some contributions to the code base. So also feel free to join that. Yeah.
Awesome. So I'm gonna put the link to the repo, Philip's Twitter, and the link to the Telegram group down in the description
Yes.
below. Philip,
Yes.
thank you very much, dude.
You're welcome.
This was awesome. And yeah, guys, see you in the next one. Bye bye.
See ya. Bye bye.